Hi, this is Mrs. Cribb. We're going to go ahead and work out the honors question from Chemistry Chapter 12. This is the bonus question, and then if anybody who is not in honors wanted to do this, they can earn bonus points. I went ahead and looked up a couple of things, and that's the molar mass of sodium, oxygen, and hydrogen right up here, because I know we're going to use it. Okay, let's read this. If I had 35 milliliters of water, if I add 35 milliliters of water to 130 milliliters of a 0.34 molar sodium hydroxide solution, what will the molarity, that's the capital M, of the diluted solution be? So remember, molarity is equal to the moles of the solute molarity over liters of solution. Okay, so the first thing I asked is, what will the final volume be? Well, what that means is I start off with this volume of 130 milliliters right here. That's 130. And then I'm going to add 35 more to it. So I put 35 milliliters into the container. So what will the final volume be when I add it all up? Well, it's going to be 130 plus 35. So that would be 130 plus 35, or 165 milliliters. That's how many milliliters when I added the additional quantity right here to what was there already. The total volume is 165 milliliters. And so that was important for you to understand. And so the answer here is 165 milliliters. And I want you to also notice there's no need to change it to liters. All right, what formula are you going to use? Well, we're making a dilution because we're adding some quantity to some milliliter to some other milliliters, and we're going to calculate a new molarity. So it's M1V1 equals M2V2. And remember, this capital M there, that is the molarity. That's what we're talking about, not the number of moles, molarity. So now the final question was going to be how many grams of sodium hydroxide will be found within the solution. So what happens is we have a solution and it has sodium hydroxide over here in it. And we're going to add additional water and dilute it so those sodium hydroxide particles can spread out evenly. And so I want to know how many grams of sodium hydroxide we're going to be found within that solution. And I just realized something, but we're going to go ahead and calculate first of all what the molarity of the final solution will be. Okay, so let's see here. M1V1 equals M2V2. Okay, we start off at the beginning with only 130 milliliters. And we have 0.34 molar solution. So 0.34 molar. Now, I wrote these kind of backwards. I put the volume there and the molarity there, but it doesn't matter because it's multiplication. All right, this is going to be equal to whatever the new molarity is, and I don't know what that new molarity is, but I do know what the new volume is going to be, because that's what this was, the new volume. Okay, so now we just need to solve for M2. So we're going to divide both sides by 165 milliliters, and it will cancel out. Okay, I went ahead and wrote that in for you. We'll have 165 milliliters canceled on both sides. The milliliters cancel here, so the unit is molarity. And now if I do the math, this times this, 130 times 0.34 divided by 165, I get 0.2678 molar, capital M, and then we need to figure out our significant figures. And our significant figures, it's 2 sig figs in both of these numbers. So this is a 2 sig fig answer, so we have to round it to 0.27 molar. Okay, that's the number, that's the molarity of the solution. Okay, that's not the final answer though. Now that I know what the molarity of the solution is, I have to figure out how many grams that is. But in order to figure out how many grams that is, I also have to figure out how many moles. So we set up a proportion now, okay? 0.27 capital M is the same thing as 0.27 moles per 1 liter. And we get a proportion. We have, instead of 1 liter, we have 165 milliliters. And so we're going to change that now to liters. So we divide by 1,000, and we end up with 0.165 liters. So this is when you need to change it. 0.165 liters, and how many moles would be in that 0.165 liters. So once we this molarity, it means number of moles per liter. Some people mistakenly think that it just means moles. No, it just means moles per liter. Set up the proportion, and now we're going to solve for x. And we solve for x by cross multiplying. So we have x moles times 1 liter equals 0.27 moles times 1.65 liters. 0.165 liters. Okay? Then divide both sides by 1 liter, and we'll have the number of moles that were used. All right, now I wrote this in here, and once we do our canceling, right, over for the liters on this side and the liters on this side, now we just have to do the multiplication, and it ends up being 0.04455 moles, because that's the only unit we did not cancel. And you really need to use units to make sure you're doing what you need to do. But again, we have to look at significant figures, so let's look at that again. 2 significant figures here. So 2, remember, leading zeros are losers, so there's my first significant figure, and my next one is right here, and I'm looking at it and I'm going to round up. Now honors could technically say 0.044, but we rounded this one up to 0.045. 0.045 moles. Okay, great. Now I know how many moles that is, and I have to turn the number of moles, because that's the number of moles of sodium hydroxide. That's how many little particles of sodium hydroxide are inside this number of moles of it inside the solution, but I want to figure out what the grams are. So lastly, I'm going to take 0.045 moles of sodium hydroxide and convert that into grams. So obviously I need the molar mass of sodium hydroxide. So that's why I went ahead and looked these up for you. We have 22.99, 16.00, and 1.01. Remember, I want you to use 2 decimal places when you do this. Now we need to add it all up and get the molar mass. When you do the adding, it's 40.00, but again, what's the unit? Grams per mole. And you need to have all of that to have a complete answer. And you need the sig figs to end here, because I asked for 2 decimal places, and when you're adding, you want to end at the decimal place. The place value is what is important for significant figures. So it's 40.00 grams per mole. And now cancel out, multiply, and you'll have how many grams that you need. And that ends up being 1.8 grams of sodium hydroxide. That is how much, right here, 1.8 grams of sodium hydroxide. Now I will say a better question would have been to also ask what's the molarity of the diluted solution first. So I think I will add that. So what is the molarity of the new solution? And we've already calculated that, and it was right here, 0.27 molar. Okay, I hope that helps you understand this question a little bit better. I'm going to give you some additional homework. I'm going to pull it up in just a second. Well, actually, what I'm going to do is I'm going to pull it up on a separate video when I make the key. So you're going to do some additional homework on practicing this concept, and then you're going to be retested on this concept, or be tested in Chapter 12 for this concept, or retested in Chapter 14. Good luck with this.